Okay, ladies and gentlemen, today we are working on chapter 5-4 again, except this time we're actually going to solve compound inequalities. So the inequalities you saw yesterday were basically the solutions. What we're going to look at today are the inequalities that we'll have to solve, and you'll end up with the solutions. So again, make sure your goal sheet is up to date. You know I will be checking it on the day of your test. So first let's activate, hey, Benji, no! Sorry guys, Benji just stole a t-shirt. He loves to grab my clothing. Anywho, let's go ahead and activate some prior knowledge. So what we talked about yesterday was the fact that we can graph the solution of x is greater than 3, as well as the solution as x is less than 4. So if I put the other bit on this graph, the part that I'm missing, which is the x is greater than 3, that would be an open circle and shaded towards the right. So if I put these two together with an and, then the solution would be the space in between 3 and 4, so numbers like 3.5. If I wanted or, the solution would be infinite. Everything on that line is shaded. So if I have an or, it would be everything. So yeah, it is possible to graph two inequalities on the same graph. And it gives us some really interesting data, especially when we pull in the and the or. So the first thing that we're going to do today is we're going to solve compound inequalities. Now, the first type is called an intersection. And that's when we're dealing with the word and. Remember, it's either going to say the word and, or it's going to be all squeezed together, like in this one. So let's look at how to solve these. When it's spread out like this, and it's just the word and, you simply solve each side and then graph it, just like you would solve a normal inequality. So we're solving this side here first. Y minus 3 is greater than or equal to negative 11. So I need to add 3 to both sides. And I get y is greater than or equal to negative 8. And I need to solve this other side here. Add 3 to both sides. I get y is less than or equal to negative 5. So to graph this, I need to draw my number line. I need to make sure that I have negative 8 and negative 5 on my number line. Alright, so with the first one, I've got y is greater than negative or equal to negative 8. So that's a closed circle and anything greater than. And then on this side, I have y is less than or equal to negative 5. So that's another closed circle and anything less than. And notice I'm not shading completely until I make my decision. Now that I can see both of these sides here are being shaded to overlap each other, I just want to make sure that my final solution is the space where both of them overlap, which is the data in between. So there's my solution. All right, let's try one that's got it all squeezed together like this. Okay, so in this case, you're going to solve it all at once. Draw two lines, one by each inequality, and then whatever you do to the inside, you're going to do to all sides. So because I have a plus 2 here, I'm going to subtract 2. And so I'm going to subtract 2 from here, and I'm going to subtract 2 from here. Now all I have to do is simplify. So that leaves me with a z. My inequalities are still the same. Remember, the only time you flip them is when you're dealing with negatives in multiplication or division. And then 11 minus 2 is 9, and 7 minus 2 is 5. Now, this might be a little bit trickier for you to graph. Remember, you can split it up. So you've got z is greater than 5, and z is less than or equal to 9. So on my number, ooh, that's not straight. On my number line, I've got 5, 6, 7, 8, 9, And for the first bit here, z is greater than 5. That's an open circle. And for the second bit, I have z is less than or equal to 9. That's a closed circle. And so you notice that the area where they're going to overlap is just the inside. Have you guys started noticing a pattern? All and compound inequalities. Actually, it's not all. Let me change that. Most and compound inequalities. I'm spelling that wrong. Inequality. That's terrible. There we go. Inequalities overlap between the two numbers. So it's always on the inside. Have you noticed that? Again, most, majority. All right, let's look at some ors. The ors we actually call a union. That's an or compound inequality. So with the or compound inequalities, they're always going to be written separate. They'll never squeeze together like the ands. So you simply solve both of them separately and then graph them. So let's solve this one on the left first. We need to subtract 1 from both sides. That gives us x is less than 3. Or I need to add 1 to both sides. So I get x is greater than or equal to 4. All right, so let's go ahead and graph that. I need to make sure I have 3 and 4, so 2, 3, 4, 5. Graphing that first bit there, x is less than 3 is going to go to the left. X is greater than or equal to 4 going to the right. So I notice with this or, the only space not highlighted is that center bit there. All right, let's try this second one. A little bit more complex, couple more steps here. So we're doing an or, so we're solving them totally separate. Let's solve this one first. Backwards through PEMDAS, so I'm going to subtract 5 from both sides first. That gives me negative 2x is less than 10. Then I'm going to divide both sides by negative 2. So, you guessed it, flip the inequality. Or, let's solve the other one. Subtract 15 from both sides. 5x is greater than 5. Divide both sides by 5. X is greater than 1. So to graph that, we got to make sure we've got negative 5. I'm going to skip by 2 so I don't run out of space. Alright, so we're doing first, x is greater than negative 5. That's going to go in this direction. Or x is greater than 1. That's going to go in this direction. So my final answer is either or. And so anything that is greater than 5 is my final answer there. Anything greater than negative 5. Because this is part of that solution. So your final answer is simply x is greater than negative 5. All right. So what I want to do now is I want to show you some word problems so you can help to understand and connect why compound inequalities are important. So what we're going to do here is we're just going to write and graph a compound inequality for this word problem. It says a ski resort has several types of hotel rooms and several types of cabins. So we've got 2 types of things. The hotel rooms cost at most $89 per night, and the cabins cost at least $109 per night. Write and graph a compound inequality that describes the amount that a guest would pay per night at the resort. So first let's define our variable. We're going to say x is the amount a guest would pay. All right, so we can write our first one based on hotel rooms are at most $89. So remember, at most means they are less than $89. All right, so now we can look at that second one. Cabins are at least 109. Cabins are at least, so that means they're going to be more than 109. Could they be equal to 109? Yes. We forgot our equal sign on the 89 because at most it could be 89. So this is x is less than or equal to 89 or x is greater than or equal to 109. So if I graph that, I'm not going to take the time to put everything in between here. We got 89, we could go 99, 109. So at 89, x is less than 89, close circle, anything less. X is greater than or equal to 109, close circle, anything bigger. Now the only thing we're missing is this an or an and? Is a guest going to spend this price and this price? Or are they going to spend one or the other? So I think you know what it is. It's an or. So our final answer is x is less than or equal to 89 or x is greater than or equal to 109. That is the amount a guest would pay staying per night at the resort. All right. So what I'd like you to do for homework tonight, ladies and gentlemen, is page 308, numbers 6 through 15. You've got a nice mixture of ands and ors. Please, please, please remember to graph your solution. It's extremely important that you practice that, and we'll check them tomorrow in class. Have a good day.